In this video, we're going to go over the combined gas law. So the combined gas law incorporates all the simple gas laws, Boyle's, Charles, Gay-Lussac's, into one law. And it's used when there's a fixed amount of gas, or N, and the variables P, T, and V, so pressure, temperature, and volume, are changing. The temperature must be in Kelvin. And the equation is the initial pressure times the initial volume divided by the initial temperature is equal to the final pressure times the final volume divided by the final temperature. The combined gas law can also help us remember the simple gas laws if we remove the temperature terms from the combined gas law equation. So if we took out our temperatures, we'd be left with the initial pressure times the initial volume is equal to the initial or the final pressure times the final volume, which is Boyle's law. If we were to remove the pressure terms and we just had volume over temperature on each side, that would be Charles' law. If we moved the volume terms and we just had pressure over temperature on each side, that'd be Gay-Lussac's law. So practice how this comes into play. At 100 feet below the ocean surface, a nitrogen bubble with a volume of 0.01 milliliters forms on the skin of a scuba diver. The pressure at this depth is 4.2 atmospheres and the temperature is 11 degrees Celsius. What is the volume of this bubble after the diver ascends to sea level where the temperature is 29 degrees Celsius? So I'm going to write out my equation first. My combined gas law equation. And then I'm going to look at all my variables. So my variables, my initial pressure, initial volume, and initial temperature. So my initial pressure is 4.2 atmospheres. My initial volume is 0.010 milliliters. And the initial temperature is 11 degrees Celsius. But this needs to be in Kelvin. And so I add 273 degrees to this, so plus 273 to this, and it comes out to be 284 Kelvin. Now I want my final pressure, volume, and temperature. My final pressure, it says ascends to sea level. Sea level is 1 atmosphere. We want to know our final volume, and our final temperature is 29 degrees Celsius. In Kelvin, this is 302 Kelvin. So now I'm just going to plug everything into my equation. So I have 4.2 atmospheres times 0.010 milliliters all over 284 Kelvin is equal to 1 atmosphere times what we're looking for all over 302 Kelvin. I'm going to cross multiply and divide, and my final volume turns out to be 0.045 milliliters. So the nitrogen bubble on the scuba diver's skin increased from 0.01 milliliters to 0.045 milliliters. So the combined gas law provides the relationship between pressure, volume, and temperature for a fixed amount of gas when moles is constant in terms of initial and final concentrations. Temperature must be in units of Kelvin when using the combined gas law.